The acceleration of an object in meters per second squared is given by the function a of t is equal to 3 sine t, and the initial velocity of the object is v of 0 is equal to negative 4 meters per second. So first it's asking find the equation v of t for the object's velocity. So one of the things that we have to remember is the relationship between acceleration and velocity is that acceleration is the derivative or the rate of change of our velocity. As we're speeding up or slowing down, that's what we call acceleration. And so one of the things is if we know the acceleration and we need to know how to find the velocity, well, we can use the antiderivative, right? Because if we find the antiderivative of v prime of t, then that will give us v of t. So this is the same thing as finding the antiderivative of a of t. So let's go ahead and find that. So we know we're finding the antiderivative of 3 sine of t dt. And this would be for the antiderivative of sine is just going to be negative cosine. So we're going to end up with negative 3 cosine of t. And of course, you have plus a constant. So here we have our general solution for this equation. And what we need, though, is the particular solution that is given to us using our initial condition. That we know that when I have v of 0, then our answer would be negative 4. So here is our v of t function. So if we know v of 0 means we're going to plug in 0, then we should get negative 4 when we plug in 0 for our t. Oops. Plug in 0. And now we can solve for our constant c. So the first thing we know is that cosine of 0 must be 1. So this is negative 4 is equal to negative 3 times 1 plus c. Or just negative 4 is equal to negative 3. And so if we solve for c by adding 3 to both sides, we get c is equal to negative 1. So our specific solution, or our particular solution, would be v of t is equal to negative 3 cosine of t minus 1. Next, it's going to ask us to find the object's displacement, meaning where did it move to? How much did it move from its original position? And so the key thing that we have to remember about a position of a particle and its velocity is that if I have the position s of t, then we can take the derivative or its rate of change, and that's exactly what velocity is. Velocity is the rate of change in our position or displacement. So if I want to find the displacement of our object, then we can take the antiderivative of that. So this would just be the antiderivative of our s prime of t, and that would give us our position, which is the same thing as finding the antiderivative of our velocity. So let's go ahead and go through this process. And in this case, we do have a definite integral because we have a specific time interval that we're doing this from. We're going from time 0 to time 3. So putting this in is saying, okay, let's find the antiderivative of our velocity function, which we already found, negative 3 cosine of t minus 1 dt. And we're doing this as t goes from 0 to 3. So let's apply our antiderivative, and this gives us the antiderivative of cosine would be sine. So we have negative 3 sine of t, and the antiderivative of negative 1 is 1t. Putting this into my calculator tells me that this would just be negative 3.4234. So let's think about this last piece now, where it's asking for the total distance traveled by the object. So this one sounds very similar to part B, where we're finding the total displacement, or the object's displacement. But here, when we're talking about distance, we have to think about it a little bit differently. So let's talk about the reason why first. Imagine if you're driving somewhere away from home, maybe you're going to work in some building. Well, if I drive 5 miles in one direction, then that's a displacement of 5 miles. And then if I drive 5 miles back, right, technically we're kind of going a displacement of -5, so we end up back in the same spot. 5 and -5 is a total displacement of 0. We're back home. But if I were to ask you then when you got home, how far did you drive today? You wouldn't tell me you drove 0 miles, even though you ended up right back in the same spot. You would have told me that you drove 5 miles plus another 5 miles in the other direction. So this is driving 5 miles plus another 5 miles. Well, why is this going to be also positive? Because when we're talking about distance, we only care about the positive aspect of it, right? It doesn't matter the direction or velocity that we're going. We just want to know the total distance. And so one way to think about this is we're looking at the absolute values of these amounts. And so for us to think about our total distance, we can think about the absolute value of our velocity is what we're using to help us out. So in order to find the total distance, we're going to do what we did in part B. We're going to take the integral from 0 to 3, but this is going to be from the absolute value of -3 cosine of t minus 1 dt. So one thing to think about is that we have, at this example that we did up top, is, yeah, we knew that we had to take the absolute value of the first part and then the second part when we go by. But here it was pretty intuitive that we knew where to break it up, that we're taking a first part plus the second part, adding those together. But when we're doing the absolute value here, how do we know where to break things up? The key thing that we noticed is we had to break it up to when we were going forward and back, when we're going in the positive direction and the negative direction. And so same thing here, we have to think about when are we moving positively and when are we going negatively. So even though we won't have a graphing utility usually, let's bring up a graph of what this would look like. So here's our function of our graph. I used x instead of t just so we can graph it out. But if you notice, when we're at x or t equals 0, we're down here in the negatives. And then when we go up here, we reach 1.911 for x, and that's when we're at 0, and then we cross over into the positives. So if we were to try and find the integral of this, we would find out that all of this would be negative distances, and all of this would be positive distances. So we want everything to be positive. So the key thing we have to realize is that, okay, we just have to turn these negatives into positives, and that'll calculate the distance rather than the displacement of going negative. And so we're going to split this up into two parts, the negative part and the positive part. And where do we split that up is at this point, 1.911. But here we had a graph to kind of give us that idea of where does that split happen? Where do we start adding the two pieces together? What if we didn't have a graph? How can we get that 1.911? Well, the key idea when we're working with absolute values is it becomes negative to positive or positive to negative when it crosses 0. So that's our goal, is we've got to figure out when is our function going to hit 0, and then we can figure out which side is negative and which side is positive. So let's do that first. We want to know when is this function going to be 0. So I'll do that off on the side. -3 cosine of t minus 1 is equal to 0. And if we solve for t, this would give us -3 cosine of t is equal to 1. And then if we divide, we get -1/3. And lastly, we'll take the inverse cosine or arc cosine of -1/3 and plug that into our calculator. And if we do that, you'll see that we actually get the same point that we saw in our graph, which was the t equals 1.911. So we're going to break this up into two pieces. this is equivalent to saying we're going from 0 to 1.911 of the first part. So I'll just put dt. And from 1.911 to the end, which was 3. So now, what do we need to do? If it's negative, we need to make it positive, which is just by making it the opposite. So for example, here, we know that to the left of 1.911, it's in the negatives. So we're going to switch it to by taking the opposite of it. Because if this is negative, then by putting a negative in front, it should make it positive. This one was already positive on the other part when we're above 1.911 up to 3. So this one we can just keep positive or keep it the same. And now we can find these two integrals and get our answer. So for the first one, I will distribute the minus sign. So we're going from 0 to 1.911 of 3 cosine t plus 1. And this one stays the same. And let's just do the left one first. So if I take the antiderivative of this, this would just be 3 sine of t plus 1t, which is t. And this is going from 0 to 1.911. And then if we do the other one, this one will be going to be negative 3 sine of t minus 1t, or just t. And again, we're going to integrate from 1.911 all the way up to the second boundary, which was 3. And let's evaluate this. So here I have 3 sine of 1.911 plus 1.911. And then we can do minus the same thing, but with plugging in our 0. So 3 times sine of 0 plus 0. And then we'll do the same thing with the other one that we have. So this one is going to be negative 3 sine of 3 minus 3 minus, then we'll plug in the 1.911. Negative 3 sine of 1.911 minus 1.911. And we'll just put this into a calculator and see what we get. And my answer comes out to 6.0548.